Hello guys, today's topic is helium neon laser. The name itself indicates it is a gas state laser. It was invented by Ali Jawan in the year 1948. We use helium neon. We use helium neon because they will emit visible light, are affordable, and have good beam quality. Helium neon usually emit at 632.8 nanometers, producing a red beam. In helium neon laser active medium is helium neon, and active center active centers are neon. In helium neon laser we use electrical discharge pumping. And it is a 4 energy level. Next we go to construction. In helium neon lasers, the ratio of helium neons are 10:1. The glass tube is filled with the neon gases with a specified atmospheric pressure individually. The ratio of filling helium neon gases are 10:1. The role of helium is to excite neon atoms. Dimensions of glass tube are 80 centimeters in length, 1 centimeter in diameter. Let us consider a glass tube. And two reflectors which are coated with silver. Which one is 100% perfectly coated and one is partially coated? These are electrodes, and it is pumping. Helium is lighter and more in number, so they emit first. Let us consider energy levels. The, the electrons which are present in ground state will excite. And they will transform. With the energy match so close, collision of excited helium atoms with ground state neon atoms results in a type of energy transfer called resonant transfer. As you know, as I say, it is a 4-level energy diagram. Let us consider it as E4 prime, E4, E3 prime, E3, E2, E1. They are of almost same energy levels. When an atom present in ground state of neon, it excited and it will spend a lifetime of 10 power minus 3. After that it will de-excite to E3 prime, E3. Thus population inversion is created between E4 prime and E3 prime and E3 and E4 and E3. After spending their lifetime, they will de-excite to ground state. The photons which are emitting from E4 prime to E3 prime will emit a radiation of wavelength 3.3 micrometers that comes under IR radiation, and the atoms which are excited from E4 prime to E3 will emit a visible light of wavelength 0.63 micrometers. Then remaining E4 to E3 will emit an radiation of wavelength 1.15 micrometers, which comes under IR radiation. So we only consider this. In the helium neon laser, the light is produced by atomic transitions within the neon atom. Helium does not directly produce laser light, but it acts as a buffer gas which is to assist or help atoms of other gas to produce lasing in a manner. The glass tube is manufactured in such a way that completely or fully absorbed. Due to narrow shape, atoms present in glass tube will collide and be de-excited. It emits continuous laser beam. Now let us talk about advantages of helium neon laser. Firstly, they have very good coherence property. Helium neon laser tube has very small length, approximately from 10 to 100 centimeters, and it is a best lifetime of 20.000 hours. Helium neon lasers can produce three wavelengths that are 1.152 micrometers, 3.391 micrometers, and 632.8 nanometers, in which 632.8 nanometers is most common because it is visible usually in red color. Current cost of helium neon laser is less from most other lasers. Construction of helium neon laser is also not very complex. Helium neon laser provide inherent safety due to low power output. Now let us talk about its disadvantages. It is relatively low power device. means its output power is low. Helium neon laser is low gain system or device. To obtain single wavelength laser, the other two wavelengths of laser need suppression, which is done by many techniques and devices, so it requires extra technical skill and increases the cost also. High voltage requirement can be considered its disadvantages. There are a number of applications for helium neon laser, in which one application is helium neon lasers are also used in supermarket checkout counters to read barcode and QR codes. Helium neon lasers are also used by newspapers for producing transmitted photographs. Barcode. Helium neon can be used in guns for targeting, and there are a number of applications. Thanks for watching this video.